We have the problem quantity x plus 5 times the quantity x minus 8 equals x squared plus 3 times the quantity 2x minus 1 minus 1. Our goal here is to solve for x. In order to solve this equation, we need to actually distribute out two of these terms. We need to distribute the quantity x plus 5 times the quantity x minus 8, and we also need to distribute this 3 times 2x minus 1. We can use generic rectangles in order to help us with this distribution. Think of it as taking the product of a rectangle and turning it into the sum of the area of the rectangle. In order to set up our generic rectangles, we need to figure out what dimensions they have to be. For the first one, because we have our quantities x plus 5 times the quantity x plus 8, each of the quantities has two terms, therefore we need a 2 by 2 generic rectangle. Our first side length will be x plus 5, and our second side length will be x and a negative 8. In order to actually distribute and compute this multiplication, we need to multiply every single term and fill in the boxes for our generic rectangle. In the top left corner, we will multiply x by x, which will give us x squared. The one right below it, we will multiply 5 times x, which will give us 5x. The top right, we'll multiply x times negative 8, which will give us negative 8x. And our last box, we're multiplying 5 by negative 8 to get negative 40. Once we have set up this generic rectangle, all we have to do is figure out the sum by adding all of the inside terms. And we will always start with the largest term, being the x squared. So we have x squared, then we're going to go off to our x term. However, we have two x terms here, a 5x and a negative 8x. We will combine those together to get negative 3x, and then we have our last term as negative 40. This will make up the left side of our equation. On the right side, we also have to create a generic rectangle to multiply out 3 times the quantity 2x minus 1. Because we have one term multiplied by two terms, we will need a 1 by 2 generic rectangle. 3 being the side length of this one side, and 2x minus 1 being our other side length. Once again, we are going to multiply these terms together to fill in our generic rectangle. 3 times 2x will give us 6x, and 3 times negative 1 will give us negative 3. This means that we can rewrite 3 times the quantity of 2x minus 1 as 6x minus 3. So when rewriting the full right side of our equation, we still have our x squared term. We now have a plus 6x minus 3, and then we also have a minus 1. In order to start solving the equation, we first need to combine any like terms that we see on either side. On the left side, there are no like terms, so we'll go ahead and rewrite that part of the equation. However, on the right side, we do have two like terms, a negative 3 and a negative 1. So we can combine those together to make negative 4. Because our goal with solving this equation is to solve for x, we want to get all of the x terms by itself. And how we're going to start thinking about solving for these equations are with algebra tiles. So we're going to split our equation so that we can clearly see the left side of the equation and the right side of the equation. We need to keep both of our sides balanced, so whatever we do to the left side, we also have to do to the right side. First, let's look at our x squared term. Let's look at the one on the left side, and in order to cancel that out, so I do not have any x squared terms on the left side, I need to add a negative x squared, because a positive x squared will balance out with a negative x squared. You can think of them like the algebra tiles. When I have a positive x squared and a negative x squared, I can take them away because they'll cancel each other out. Whatever I do on the left side, I also need to do on the right side of the equation. This so happens to cancel out both of my x squared terms. So both of the x squared terms on the left side and right side will cancel out. This will leave me with negative 3x minus 40. equal to 6x minus 4. Once again, our goal is to get all of the x terms on the same side of our equation. In order to balance out this negative 3x and cancel it out, I need to add 3x. And to keep my equation balanced, I need to add 3x to both sides. This will cancel out that term on the left side and leave us with negative 40. 6x plus 3x will give us 9x. We still have that minus 4. Because we want all the x tiles to be all by themselves, we need to get rid of those negative 4 1 tiles. And in order to do that, we can add 4 positive tiles to cancel out with the 4 negatives. This will leave us with negative 36 equal to 9x. And then finally, to get x all by itself, we need to use division. And the reason why we're using division is right now we have 9 times x, and in order to undo multiplication, we have to do the opposite, which is division. So we will divide both sides by 9. This will leave us with negative 4 equal to x as our final answer. However, we always want to double check that we did get the correct answer by plugging back our answer into the original equation. So everywhere you see x, we will put a negative 4. So we have negative 4 plus 5 times negative 4 minus 8 equal to negative 4 squared plus 3 times 2 times negative 4 minus 1 minus 1. Okay, let's slowly break this down. So first we want to use order of operations when we're going through this. So we're going to look at the parentheses first. Negative 4 plus 5 will result in a positive 1. Negative 4 minus 8 will give us negative 12. We can go ahead and do the exponent. Negative 4 squared. Whenever we square negative, we'll get a positive. We have plus 3 times 2 times negative 4 is going to give us negative 8. Minus 1 will give us negative 9. Minus 1. Okay. 1 times negative 12 is negative 12. This equals to 16. 3 times negative 9 will give us negative 27. Minus 1. So we have negative 12 equals 16 minus 27 will give us negative 11 minus 1, which will give us negative 12. So since negative 12 equals negative 12, that means that negative 4 is our correct answer, and we have successfully solved for x.